The big question is, can CO2 levels actually be driving our worldwide climate? Most scientists go by the scientific method to determine whether their studies are correct or not, and this kind of outlines that. And basically, you have a hypothesis, and then you test the hypothesis. If your test matches, if the results match your hypothesis, then you may be right. It may just be by chance that you match, but you may be right. But if your results don't match the hypothesis, you're 100% wrong. And you got to go back and change things so that they do match. And that's the whole scientific method of things. And so far, none of the gloom and doom models have successfully predicted future weather patterns. This is not surprising, since no one has been able to explain why the Earth has gone through 4 ice ages in the last 400,000 years. If they can't explain the past, what makes them think that they can predict the future? This is a chart that shows the global temperatures over the last 400,000 years, and you'll note that each one of those is very similar. Even the ups and downs during the cycle are very similar, and no one has any idea why. But one thing is that every 100,000 years or so, the Earth heats up for about 15,000 to 20,000 years. And looking at the cyclic nature of past global temperatures, it's clear that it's not driven by anything on Earth. Things on Earth are too random and short-lived to cause these changes. Our warm time is about up if this cycle continues. You know, how soon is soon? 200 years is about the width of a line on the graph. So our global scale, it could be as little as 1,000 to 2,000 years. It's been said that talking about climate change, if you're talking about a period of less than 10,000 years, you don't know what you're talking about. Now this chart shows the same thing with CO2 levels superimposed. And this comes from ice core data. And the way they get the CO2 levels is in ice, there's little bubbles of air entrapped in the ice. And I don't know exactly how they do this, but basically they're able to capture that air and see how much CO2 is in it. It could be, since water absorbs CO2, as you'll learn shortly, that some of that is absorbed during the melting process. So the CO2 levels that show here may be lower than they actually were. But the point is that all of these data were collected using the same method. So the relative position is going to be the same. It may be a little bit higher, but everything would come up. The other important thing to look at when you look at this graph, if you study it carefully, you'll find that the CO2, pretty much mirrors the temperature. But when you look at it closely, you'll discover that the CO2 levels lag the temperature, not lead the temperature. And the other thing is that these data points, there's one data point every 800,000 years to 1,000 years in the out periods. So there's a lot of things that can be happening in between these data points. Now, this is the last 120 years, and of course, by this time we have thermometers and things like that, so we can have some pretty good, much more accurate data. And these are the data that Al Gore uses to show the increase in global temperatures during the Industrial Revolution. Note that since the spike in 1998, the trend has been downward in spite of increasing CO2 levels. But as you will see, over the short haul, temperatures are always changing. These data go back to just before the American Revolution and show the end of the mini ice age, which ended about 150 years ago and started about 700 years ago. This may explain why in all the paintings that you've ever seen of Washington crossing the Delaware, they show huge chunks of ice in those paintings. I don't know if anybody else has noticed that before, but I always wondered when I was growing up, why all this ice? Well, it was a heck of a lot colder back in the Revolutionary days. And Now this graph shows the last 1,000 years, and note that about 400 years ago, global temperatures were significantly higher than we had experienced recently, and that spike occurred during the mini ice age. Note that the rapid temperature fluctuations between 200 and 600 years ago, these are several times larger than we have experienced recently, and all this happened long before man-made CO2 was a factor. Note that and this is going back to 5,000 years, note that 3 periods where global warming temperatures exceeded our recent high temperature. One of these lasted for several hundred years. And this graph covers a period from the coldest part of the last ice age to the present. Note another extremely high spike about 8,000 years ago. None of these spikes could have possibly been caused by human-produced CO2. Now we're back to this, we saw this slide earlier, but you notice that gradual coming out of the ice age on the previous slide, that line is almost vertical when you look at it on this scale. Now this shows CO2 levels and temperatures over the last 600 million years. And it's interesting, we don't have time to go into how they get these data, but they get it from a variety of ways, and they worldwide, and they correlate with each other. So there's pretty good evidence that these are, relatively accurate. So 525 million years ago, CO2 level was about 700 million or 700,000 parts per million. 450 years ago, 450 million years ago, the CO2 level was about 4,000 ppm, and at that point, the Earth was in an ice age. 300 million years ago, CO2 was below 500 ppm. You can see that down, that dip down. The only time it's been this low in the past 600 million years until now. And, just recently you can see that it's recently in these kind of terms. I mean, we're talking thousands of years ago, but so now we don't get any energy, any heat energy from the sun. Heat cannot travel through the vacuum of space. We only receive radiation. When it hits the Earth, it is either reflected back into space or absorbed and converted to heat. The heat can then be dissipated by conduction, convection, or radiation, the 3 ways that you can transfer heat. The radiation is in the form of infrared radiation. And if you ever have seen these guns that you can use in your house to figure out where you're losing heat, or the police can be in a helicopter and see a person on the ground, a long distance away, and that heat signature shows up, and it's one temperature relative to the other, and that's all infrared radiation. Everything emits infrared radiation, and the question is, what's around it? Is it hotter or colder? And it's always going to flow from the higher temperature to the lower temperature. That's where we get into the greenhouse gas effect a little bit, because greenhouse gases, in fact, will absorb infrared radiation. That's why the air can warm up. If we didn't have infrared radiation, or if we didn't have greenhouse gases, we would probably be in an ice age right now, and the Earth would be a very cold place, because there'd be nothing to keep all the heat that hits the Earth from just radiating back into space. And these are the 3 kinds of radiation, or heat transfer. Radiation, which, you think of a radiator in a house. Think of this room. If we had a couple of radiators around the room, and there was no greenhouse gases in this room, the air, there'd be nothing to heat the air except the heating on the air that was actually in contact with the radiator. So the greenhouse gases is what makes us relatively comfortable. So that's important to understand about how radiation works. Conduction is 2 things in physical contact with each other. The heat flows between them. And convection is heat that's transferred, like most of our houses that are forced air heating. The air is heated in the furnace and then blown, that warm air is blown around your house, and that's convection. And these are the primary greenhouse gases. Most of you probably don't realize that water vapor is a greenhouse gas. As a matter of fact, it's a much stronger greenhouse gas than CO2, and there's 100 times more of it than there is CO2. But you know, it's kind of hard to demonize water vapor. So you know but you look at that and you see that you got water vapor, you got CO2, and then you got methane and nitrous oxide and a bunch of trace gases. But their levels are so low that they don't really play a factor, in spite of, you know, everybody saying that the cow flatulation is gonna heat up the whole world. There isn't enough methane to even be a factor in this. And how a greenhouse works. Basically, the light comes through the glass or whatever it is in a greenhouse and hits the plants or whatever's in the greenhouse, and they get warm. And that radiation from those plants then warms up the air in the greenhouse, and that's how the greenhouse stays warm. But the key to having a greenhouse work is it's a closed environment. There's no convection out of the greenhouse. If all of a sudden the shell of the greenhouse went away, that warm air would just blow away and absorb, you know, get absorbed by everything around it. So it's the convection or lack of convection that makes a greenhouse work. Everybody knows if you have a car sitting in the hot sun, if you crack a window a little bit, it'll stay a whole lot cooler in there because the hot air can escape. Okay, in the atmosphere, the greenhouse gases are warmed by radiation from the ground and from the water or whatever's there, and it heats up the air. Warm air rises and it gets up into the upper atmosphere, and in the physics of heat or of fluid dynamics, the pressure is less up there, so that causes it to cool off, but it also can form clouds and all sorts of things. I mean, you're talking about a system that is unbelievably complex. There are so many factors in the formula, if you will, to figuring out what's happening with the weather that it's impossible to really understand it all. But the gas can be, the greenhouse gases can warm the other gases around it by convection, or by conduction, I'm sorry, and that's basically how the air, all of the air gets heated. But, okay, what is infrared radiation? We've already gone over this a little bit, and we're really short on time, so I'm going to just skip this graph. Okay, a little history. 95% of the atmosphere was water vapor. When the Earth finally cooled down to 212 degrees, that water vapor started to condense and formed the oceans of the world. And when that was all done, basically the atmosphere, and that happened where the atmosphere was virtually all greenhouse gases. So you know, it's hard to say that greenhouse gases cause global warming when we know that the Earth cooled when there was nothing but greenhouse gases. And an interesting point is that it's estimated, and I've looked at charts and done some calculations, and when I first read that, 300 million cubic miles of liquid water in the Earth. I mean, that just blew me away when I read that. But when you start looking at how a 1,000 square mile block in the oceans, how small that is when you stick that in the oceans, and then the ocean, and that's 1 million cubic miles if it's just a mile deep, and the oceans are many miles deep in a lot of places. And so that 300 million cubic miles of water is an amazing amount. And most of the world's CO2 is in solution in that water of the oceans. And let's go on. Okay, now we get to Henry's Law, and this is kind of the crux of the matter. We already talked about how soluble water is, or CO2 is in water. That's why CO2 is what we use in carbonated drinks. You can put CO2 in solution in a carbonated drink, and it stays in solution. And the amount of CO2 that can be absorbed is a function of both pressure and temperature. If the temperature is constant, then it's a function of pressure. If the pressure is constant, then it's a function of temperature. And if neither one of them are constant, it gets a little bit more complicated. But the bottom line is that as water heats up, CO2 comes out of solution in the water. And when you think of global warming over the last couple hundred years, all the oceans of the world is the big heat sink. And so as the oceans of the world heat up, all the CO2 comes out, or a lot of that CO2 comes out of solution in the water, and that's what's causing the rise in CO2. That's why CO2 lags temperature in those other graphs that we were looking at. And this is Henry's Law as compared with actual data, and those lines are very close to being right on top of each other. The difference is that the Henry's Law calculations are based on water temperature, seawater temperature, where the actual data is based on air temperature. But this shows the correlation between the two. Oops. So the bottom line is the reason that CO2 is going up is that the oceans are getting warmer, and it's exactly what you would expect. And this is what Al Gore was hanging his hat on. He observed that since the start of the Industrial Revolution, temperatures have increased and the levels of CO2 have increased linearly. Therefore, the increase in CO2 is caused by the increase in temperature, and man is causing that CO2 increase. That's the whole thesis of what Gore was talking about. There's only 3 things wrong with this. The increase in temperature caused by the increase in temperature was what caused the CO2 to rise, not the other way around. The increase in CO2 caused by the Industrial Revolution is very small compared to the other CO2. When compared with all the greenhouse gases, it's almost immeasurable. And then the real killer is a relationship between absorbing infrared radiation and greenhouse gas concentration isn't linear, it's logarithmic. And we'll get into that in a minute.
You look at a very small piece of road.
Okay, I'll see if I can. Beer's Law is the important thing that shows what infrared how radiation works. And this is, using Beer's Law, you can see that it takes very little infrared radiation to cause a lot of heating. But if you look at the ppm down at the bottom, we're sitting around 300. So if we go up to 400 or 500, the change is virtually minuscule. And here's a kind of an interesting graph. This shows you the different greenhouse gases and their concentrations, and the percentages are what are estimated to be the man-made part of it. And what they're trying to tell us in this CO2 business is that the 0.1% of the CO2 that's man-made, if we can just lower that just a little bit, and look where that is compared to water vapor, you know, just lowering that CO2 just a little bit is going to solve all the problems of the world. It just doesn't hold water, so to speak. Now, the IPCC is one of the bodies that's behind all this, and you got to understand the IPCC is a political body, not a scientific body. It's the IPCC politicians who pick the scientists who go on it, and and they decide what gets published and what doesn't get published. So it's anything but a pure scientific thing. And when you get guys like Al Gore saying that if you don't believe in man-made global warming, you're going to go to prison. You know, you wonder what the heck they're really talking about. It's like, remember, well, we don't remember, but if you've read in the history books, there was a time that you could be killed if you didn't believe that the earth was flat. And I think I just got one or two more. So the final thoughts, we don't have a clue what's causing the global changes in the last 400,000 years, and you can read the rest of it. But everybody's heard about this 97% of scientists. I wanted to read this because so I'm sure I have it right. In 2009, a survey by Peter Dorn and Maggie Kendall and Kendall Zimmerman of the University of Illinois reported the results of an opinion poll that 97% of scientists thought that mankind was having a significant impact on climate. They polled 10,257 Earth scientists, and of that, 3,146 responded. Out of that 3,146, they selected a group of 79 individuals. 97% of that 79 agreed that global warming was a factor. And, but they published this, and it got out, and people still believe that that's good data, but it's been completely debunked. And so, with that, any questions? Oh, yeah.
We have a Rotary Club.
That's right. Thank you very much.
Thank you.
Thank you.
Thank you.